Good day, everyone. Today we are going to discuss an important trenchless construction technique called pipe jacking, also known as microtunneling. In urban areas, laying underground pipelines by digging long trenches can create traffic congestion, damage existing utilities, and cause inconvenience to the public. Pipe jacking provides an effective solution by installing pipelines underground with very little disturbance to the ground surface. This technology is widely used for installing water supply pipelines, sewer lines, stormwater drains, gas pipelines, and utility conduits, especially beneath busy roads, railways, rivers, and airports. Let's understand how this modern construction technique works. Pipe jacking is a trenchless construction method in which prefabricated pipes are pushed through the ground using powerful hydraulic jacks. At the front of the pipeline is a jacking shield or microtunneling machine. As the machine excavates the soil, hydraulic jacks push the pipe sections forward from behind. The excavated soil is continuously removed from inside the machine, while new pipe sections are added one after another until the required pipeline length is completed. One of the major advantages of this method is that the installed pipeline itself becomes the permanent structure, providing a strong and watertight system. Generally, pipes ranging from 150 mm to 3,000 mm in diameter can be installed using this method. The pipe jacking process begins with the construction of two pits: thrust pit, also called the launching pit; reception pit, also called the receiving pit. The hydraulic jacks are installed inside the thrust pit. A strong thrust wall is constructed behind the jacks to resist the large pushing forces generated during pipe installation. If the soil is weak, additional support such as piles or ground anchors is provided to prevent movement of the thrust wall. The reception pit is made large enough to safely receive the jacking shield at the end of the drive. After the machine starts excavating, pipe sections are pushed forward continuously until the machine reaches the reception pit. This diagram illustrates the components of a typical pipe jacking setup, including the jacking system, the receiving shaft, and the various support systems required to ensure the machinery operates correctly during the tunneling process. Notice that excavation takes place only at the front face of the machine, while hydraulic jacks push the pipeline from behind. Modern microtunneling systems use advanced guidance technologies such as laser guidance systems, gyroscopic navigation, closed-circuit cameras, computer-controlled steering mechanisms. These systems help maintain accurate alignment throughout the construction process. One of the biggest strengths of pipe jacking is its high level of accuracy. Modern guidance systems allow the pipeline to be installed with an accuracy of just a few millimeters, even over several hundred meters. This precision makes pipe jacking highly suitable for crossing beneath highways, railway tracks, rivers, airport runways, and densely populated urban areas without affecting existing structures. Before construction begins, proper surveying is essential. For short and straight pipelines, conventional surveying methods are generally sufficient. However, for long-distance or curved alignments, advanced guidance systems such as laser alignment, gyroscopic navigation, total stations, GPS-assisted surface monitoring are used to continuously monitor the position and direction of the machine. Accurate alignment helps prevent deviation and ensures that the pipeline reaches its intended location. Before selecting pipe jacking, engineers perform a detailed geotechnical investigation. Important parameters include soil type, groundwater level, rock conditions, existing underground utilities. Understanding these conditions helps engineers choose the appropriate excavation method and minimizes the risk of ground settlement or machine deviation during construction. Pipe jacking has numerous applications in civil engineering. It is commonly used for installing water supply pipelines, sewer pipelines, stormwater drainage systems, gas pipelines, electrical and communication utility conduits, crossings beneath highways and railway lines. Because it requires only two pits, it is especially suitable in crowded urban environments where open excavation is difficult. Pipe jacking offers several important advantages. It is a trenchless technique, so there is no need for continuous excavation. Traffic movement is not interrupted. Projects can be completed more quickly in congested areas. Pipeline joints remain watertight, reducing future leakage. Environmental impact is much lower than conventional trench excavation. Public inconvenience is minimized. Construction can even be carried out beneath rivers, railway tracks, and major highways. Despite its advantages, pipe jacking has some limitations. The initial construction cost is relatively high because specialized equipment is required. Skilled operators and experienced engineers are essential. Proper safety measures must be followed during pit construction and tunneling. Detailed planning, accurate surveying, and thorough geotechnical investigation are necessary for successful execution. However, in urban infrastructure projects, the long-term benefits often outweigh these limitations. To conclude, pipe jacking is one of the most efficient trenchless technologies available today for underground pipeline installation. It minimizes surface disruption, maintains traffic flow, protects existing infrastructure, and provides a durable, watertight pipeline. With the increasing demand for underground utilities in modern cities, pipe jacking has become an indispensable construction technique for civil engineers. Thank you.